Good morning, ladies and gentlemen. If you've just come in to this huge keynote hall here at 11th Cloud Expo Silicon Valley, good morning, good afternoon, good evening. If you're joining this next general session out there on the World Wide Web via SYS-CON TV. I said don't leave your seats. I'm glad you haven't done so. We're going to redefine the word impact during this session. The impact of big data and cloud on data connectivity with some twists. Take it away, sirs. Progress Software.
We'll try that again. Good morning.
Good morning.
There we go.
Good morning.
I was really hoping I did not have to yell for this entire session. My name is Jesse Davis. I'm Director of Product Management, Director of Research and Development. I am not Jamie Merritt. Jamie's laughing at me now. I do not want to be a product manager. At DataDirect, I've been there about 15 years. Some interesting things as I've sat through some sessions here at Cloud Expo. I've got a chance to meet a bunch of new people. One of the cool things that I think has really struck me about Cloud Expo this time is just the myriad of different perspectives that you get on the cloud and big data. You know, we sat through John's session this morning, did a wonderful job. And, you know, coming at a very broad perspective, from our perspective, I'm going to narrow that a little bit and talk about the impact that cloud and big data have had on data connectivity. How many in the audience, I'm curious, we've got vendors here for hardware, we've got guys who do software, SaaS, on-premise applications. How many of you know what ODBC is? Wow, way more than I thought. Fantastic. All right, so how many of you are building or build or work with SaaS-based applications? All right, now I'm going to ask another question. How many of you know what Hadoop is? Yeah, that's what I thought. So there's a lot of people in the room. Data over the years, 15 years ago when I started this, data was not nearly as cool as it is today. Data to me now it's just kind of cool. We've gone from this thing that was really back office applications and how it was used to now data connectivity is in the forefront of a lot of really big conferences and a lot of really big conversations because it's gotten so complex. And to talk about this impact, you know, I talked about having many different perspectives from people I met. I met a gentleman at our hotel this morning who comes from a consulting group, and he's like, you know, it's interesting to talk to people because everybody has a different perspective on cloud. So I want to take you back in time so that you can, for just a few minutes, look at this from the perspective of someone based in data connectivity. I'm going to take you back to the beginning. Not necessarily the real beginning, right? We're going back to the 1970s. Back when computing was very different than it was today. How many of you were doing any type of computing in the 1970s? All right, so we do have some people who are going to understand this perspective. How many of you started computing at some point in the 1980s? All right, 90s? Wow. Past then, young guys. There you go. All right, fantastic. So we're going to kind of take a tour, if you will, through history and just look at how data connectivity, right, talking from the data connectivity perspective, has changed and has been impacted by a lot of different technologies. So I want to start, as I said, in the 70s. That is not me with the beard there in this picture. But been working on some things a little bit like this. These are computer studies in the 1970s that were really pivotal for data and data access. There was a paper written by a gentleman, E.F. Codd, where he proposed what is now known as the relational model, right, on how to think about databases, data access, disconnecting the schema and the metadata from the actual physical storage methods. Right, so you can actually begin to understand how this is a paper on how relational databases were designed and built. Prior to this time, your data lived actually within your applications. So if you were writing an application and that application had to store data, it kind of stored it in its own memory space, or it stored it locally and was accessed. And this paper not only said, hey, let's take your data and move it to a more centralized location, but let's abstract that away so that it could be accessed from many different types of applications. Freeing you, we're talking about, you know, freeing and simplifying through cloud. This is freeing and simplifying on-premise, really, your data to be accessed not from a single app, but multiple applications. Based off of this paper, that COD wrote. In the later 70s, between 74 and 77, we had a lot of interesting research projects. Many of them, you know, I would say local to California, or this side. I'm from North Carolina. You probably thought I was from Boston with my accent. But anyway, in the 70s, between 74 and 77, we started to build prototypes of some systems. One of them was Ingress. Some of you may remember Open Ingress, or the Ingress system, which was developed at Berkeley. This actually led to the Open Ingress database, Sybase, SQL Server, and then it used Quell as the query language. And then there was another system, System R, developed by IBM, which, as you can imagine, DB2 was built off of, but also Oracle, Allbase, Tandem's Nonstop SQL, and they used SQL, longer word, not SQL, as its query language. Now this is actually moving databases forward and the storage of data forward, but there's already some issues with it that we'll see as we move from the later 70s through these systems as they begin to mature a little bit. Let's take a look at 80s application architecture. So say I was going to write, in the 1980s, starting up a company, and I wanted to write a reporting application. Now back then, we had usually a single database that stored the information that I was interested in. In this case, I'm going to say DB2. And what I did was I would write my application, but it would be DB2-centric, right? There was an API supported by a client library that was written to from my application. Now, some of the problems with this, for example, is I wanted to merger or buy another company. So I would buy said company, bring them in, and I found out that they chose SQL Server. Whoops. Now I'm in trouble, right? Because I've got two different reporting apps, two different clients, and two different databases that use different query languages, that use, you know, it's just not the most optimal form of communication. We can do better. So as we move forward past that, at the same time, there was also this idea of the database wars. I'm curious, some of you guys who said you were around in the 80s, how many of you remember the consolidation and how fast companies were getting bought and merged and basically moving into more functional, faster databases? Right, one company, I see a gentleman over here, he's grinning and he's raising his hand. Good man, thank you. I'm not alone. But the database wars were basically a time where we consolidated all the different databases and companies that had been building these technologies into just a handful or just a few major players. And what this does is it tends to simplify the situation where you've got now just a few key players that you need to worry about, but you still haven't really solved the issue of having to have multiple languages, multiple APIs to access each of these different data stores. So what we need is we need to continue to simplify the stack so that it's more easy to open between. So after the war, we'll say we had a renaissance. I'm an API guy, right? I like ODBC. ODBC came about in 1992, 20 years ago, which makes me feel just a tad bit old. But it basically gave birth to the idea of standards-based data connectivity. John was up here previously with the Rackspace, and he said we use the term lock-in, vendor lock-in a lot of these conferences. DataDirect has always taken a Switzerland approach, right? If you have a database and they want to lock you into using Oracle, my job is to free you from that and present the same API through ODBC or JDBC that you could write your application once and run it against any database to trade out an Oracle driver for a DB2 driver, for a SQL Server driver, or a MySQL driver, and them all behave the same. To present to you a common API. And this renaissance that begins with ODBC, it continues to move forward with JDBC, other types of language bindings and APIs that really allow you to access your data the way that you want to from your application from anywhere. So as we keep going, this renaissance gave birth to the idea of what we call a wire protocol driver. Right? This is a driver architecture, and at the top you have your application code. That's the stuff that you write. And you write to an ODBC API, which is this non-wire protocol driver. That's the actual interface that you coded to. Now that communicated over the wire to what was a database client library, which then subsequently communicated to the underlying database. It seems a little complicated. I think we can do better than that. And so what we tended to do is as we continued to simplify the overall application architecture, we were able to invent and simplify the driver architecture so that you have what you have today, which is a wire protocol driver, which frees you from any type of client library. It reduces the amount of deployment complexity. Before, when you had a client library, your library was tied to your database version. So if you had version 8.0 of the client library, you can't use version 8.1 of the server. Right? We freed you from that, allowing you to have what you have today, which is a simple, single little driver module that we produce that you stick into your existing applications to be able to access a myriad of data sources. Right? All the version complexity, everything's gone, simple deployment, simple embedding solution. So we're continuing to move forward through the 90s to get to who is DataDirect. We've been around for a long time. We've spent 20 years solving these types of data connectivity problems, all the way through the database wars. We used to have an Open Ingress driver, if anybody remembers what Open Ingress is. And our goal is to be able to connect any application that you can write to any platform on any data source. And I'm not going to go through the statistics down here, but we're used by a lot of companies. But you may not know our name because, again, we're the database layer. We're that last bastion before you access your. Do you guys, have you ever co-presented with anyone? How many of you have ever co-presented with someone? Has your co-presenter ever fallen asleep on the front row? Okay, so Jamie's fallen asleep. Jamie says, and remember, I'm introducing you in a few minutes. Jamie says, isn't this supposed to be about cloud and big data? Yes, you're right. So I've given you a little bit of history, taking you through up to where we are nowadays with the kind of driver situation we have. Everybody's kind of happy with drivers. You plug them in, you get the one, and it just connects you. Well, if my goal, remember asking you to look at it from my perspective, is to take any application you write on any platform and connect it to any data source, it's kind of exploded. And history is repeating itself. We've gone backwards in time. Remember where the database wars consolidated everything? We now live in a poly-DB world. We live in a world where you don't have one single database that your entire company uses for everything. You use different things. You have a department that runs your website that's gathering all of your web logs and dumping it into Hadoop and running big data analytics on it. You have your Salesforce using Salesforce.com, which stores all of your critical customer data somewhere other than on-premise that you want to access. The database wars are upon us again. If you take a chart, I can't remember where I saw it last, there's a chart floating around the internet that actually shows you consolidation in cloud-based data companies that's happening right now today. And what's worse is as we go this any message that I just said, it's not just about databases anymore, right? We've now gone back to trapping our data inside applications again. Salesforce.com is an application. Workday is an application. Concur. All of these things are applications, and that's where our data lives again. It's no longer a place where you centralize your data as we had done before. It's gotten a lot more complicated. We don't just have Solaris and HP and Linux and Windows. We have those in the cloud, right? We also have things like Heroku. We have things like Force.com, which in themselves are platforms in their own right that we have to support. So from a data connectivity perspective, the perspective I'm bringing to you this morning, things have really changed. It's been a big impact on us going forward. How do we consolidate? How are we going to stay relevant in this space and still maintain our vision of being able to help you connect your data? Because you want to spend time focusing on your SaaS application. You want to spend time focusing on the things that you're building, not on your data connectivity. That's my job. If you look at big data, we're throwing up numbers up here earlier. This is a great quote from Eric Schmidt that I like that he said in 2010. We're creating as much data in 2 days as was created in all of human history up to 2003. Noodle on that for just a second. That's a heck of a lot of data. You know, I'm looking out in the audience right now, and I'm seeing John Bates take my picture. He's going to post it on Twitter. Thank you, John. You know, Jamie was tweeting that he was falling asleep, and I called him out on it. You know, what Uncle Fred had for dinner last night's going up on Facebook right now. You know, and it just continues to skyrocket. You know, John had a slide up here that had big data, and it was just stacking to the ceiling. If you look at the sheer amount of data that we're creating from all these different places, right? All the data on Sandy from NOAA, right? All the space shuttle and space junk tracking that's floating around the Earth from NASA. Like we said, what you had for dinner last night from Facebook. I'm so excited the Temptations are coming. I want my picture, right? New York Stock Exchange, trading that's going on. What's interesting from IDC here is they said the amount of global digital data generated is going to reach 2.7 zettabytes, which is a 48% increase from last year. Now, last year they predicted that this year would reach about 35% instead of 48%. So the hockey stick continues to accelerate. Big data continues to get bigger. How do we process it? How do we deal with it? How do we connect it to our applications that we have today? Now, I do have a pop quiz. I want to try to keep this exciting. Last thing I want is for Jamie or any of the rest of you to fall asleep again. So I do have a question. What comes after the zettabyte? Does anybody know? We've been talking about exabytes and petabytes and now zettabytes. Cloud Expo number 15, Attabyte. The Yodabyte, which is unfortunately not named after my favorite Star Wars character, and after recent events, is now my favorite Disney character. For those of you who don't know, the Lucasfilms has been bought by Disney, so more Star Wars movies. There you go. So as we continue to look at it, this really makes a perfect storm of data complexity. You've got waves of big data, just mountains of this stuff that you got to process and make useful. I mean, the idea of big data is for you to take all this data and get some really interesting information out of it. We have a session later today, politics. I'm not going to get into too much politics up here, but at one of our later sessions this evening around 6 o'clock, when you're all going to be glued to your TVs and watching the news and stuff, they're going to be looking at live Twitter streams between the two different campaigns that are running. And now we've also got cloud thrown in there. Not only do we have this big data, but we also have this data and this explosion in the cloud, and then a poly database world where you have multiple databases, multiple data stores living alongside each other within your organization. How do we deal with it? It's a big deal. So let's take an example. Let's start looking at a perspective of someone who is going to write a SaaS-based application, right? The first perspective to look at is how do I, look at my application connecting to my data. I'm building this SaaS-based application. It's going to have some data in it. I need to provide performance. Big deal. Make the user experience as fast as possible. So performance when connecting to that data is interesting there. How do their applications connect to my data? I'm going to have SaaS-based customers. For those of you who are familiar with Salesforce.com, their reporting infrastructure is, when you run a report on Salesforce.com, it's really not as good as something like Tableau, right? You can't drill down into it. You can't click on it and, you got sliders and moving and making everything look really great. So you need to think about how customers of your SaaS application can get to the data that's inside of it. And then how do my applications connect to their data, right? You might want to add data sources. Add data connectivity to your SaaS app. You might write your SaaS app and have it connect to one thing, and then next year you need it to connect to 4. And then the last one's how do their applications connect to their data? I'm a SaaS writer. It's not my problem. I'm not going to worry about that. So this is what we call our box line can diagram. Any of you architects or software engineers have ever really drawn on a whiteboard what an application architecture looks like? It's a box, a line, and a can. Now, from my perspective, as we're taking a tour of different perspectives here at Cloud Expo, from my perspective, that line gets really, really big. This is how I look at data connectivity. There's a lot of stuff in that guy. There's data conversions. There's internationalization. I need to know where I am. I need to know how to make sure that you can read the data, the string data that you get back from me. One of the gentlemen in the previous session asked a question, all of this data that we're transferring around, how are, Ethernet cables and wires and networks and bandwidth going to work? Well, one of them is you got to be able to tune your socket management, socket buffers, network wire management, those types of things. How do you do bulk load? Is there another protocol by which I can bulk insert and extract data? Right? And then on the front end, how do I make all those sources look like one thing to my application? This is what I'm looking for. Right? And so when we talk about performance, how's it going to perform? 75% of the transaction time in a well-tuned app is either in the driver, the disk I/O, or network communication. Those of you who have ever done performance tuning, as fun as that is, you've got to take into consideration the physical speed of your hard drive, how fast your network is, and all of that stuff is at the data connectivity layer. So I want to run you through a real quick example of how do you fix that. You can either add infrastructure by throwing money at it, or you can remove the bottleneck. So as a use case, let's take this SaaS application. I'm going to build it on Amazon. And we're going to use several different options here. We're going to run a performance tuning scenario on a small or a micro machine, a medium machine, and a large machine. And all three of these are going to connect to a database server on a ginormous machine. And yes, ginormous is a real word. So as we look at this, this is an account balance. So think small transactions, really fast, like an ATM machine withdrawal. Right? This is the scenario we're running. So in this case, you're running just two different pieces of data connectivity. Your app is the same, your machine is the same, your data server is the same. 2 times the throughput on the same machine. That's pretty good. That's pretty good. That's worth trading it out, depending on how big the application is, how many customers I have subscribing to my SaaS application. That's not bad. These are on the micro machines. Now, over here, I'll take a second. You have rows per second, so that's how many rows every second I'm able to feed through. And then on the bottom, we're simulating threads. So I think that's number of users. So as the number of users increase, are we scaling? You can tell by the shape of the graph. Is the graph going up? Are we getting resource bound? Let's take a look at the next one. It'll become a little more apparent. So on this one, we're on the large machines. The top blue line and the brighter red line on the bottom. If you notice, both of them become resource bound on these machines. At 8,100 rows per second, the competitor gets resource bound and starts degrading in performance. We had a slide up on the previous presentation where they said Gadget went, who remembers, from 0 to 55 million page hits over the course of 2 hours. Right? Neither one of these connectivity solutions really would suit you there. 27,000 rows per second is going to start coming close, but only at 50 threads and 55 million page hits, you need more scalability. So let's put it on a bigger machine and see what happens. Okay, this is looking better. So now we've removed the hardware from the equation. Now it's down to the connectivity solutions themselves. Between these two lines, the top line is still scaling and increasing margin. That means that as you continue to throw more at it, you go from 0 to 55 million users, that connectivity solution is still going to be providing the same amount of throughput, nay, even more throughput for your applications, meaning you're getting no slowdown. The bottom one is still going to be scaling, but you're scaling at a much smaller rate. So what does that mean for you? We gave you two options in the beginning. I said you could either throw infrastructure at it, in which case here you throw infrastructure at the bottom one and you're getting somewhere on the neighborhood of 15,000 rows per second. And if you throw infrastructure at the top one, you're getting between 40 and 45,000 rows per second and still scaling as the number of users increases. So what does that mean to me really? When I build a SaaS app, what does that mean to me? I really want to save that money, Jesse. You said I could throw money at it, but I really don't want to do that. I want to remove the bottleneck. So what you can do is if you look, I put a little chart down here. I swear I'm not a marketing guy. So say you were running on 20 servers. What this means is you can reduce the number of servers that you need to maintain your load. So you can go from 20 to 8 servers and save yourself between $100,000 and $150,000 over 3 years, which ain't bad. And as that number continues to scale up, you can go from 100 servers with the competition. You only need 35 servers up and running with this connectivity solution, saving yourself between $500,000 and $750K. That's a lot of money. You could buy a lot of stuff with that. Now, what's interesting about this is comparing the cost of running what you would call free data connectivity against, something else. Our data connectivity. Mine's not free. But the interesting piece there is the cost savings that you get does not include licenses. So if you have 20 servers running here, and those servers also have other software, you can save on the licensing by shrinking down the number of machines that you need. So that's looking at the perspective of how do my applications connect to my data. How can I make sure that my SaaS application is performing as fast as it possibly can by changing out the data connectivity? That's in the cloud. Now, continuing to look at it from that perspective, how do their applications connect to my data? I already have an API, right? You may have an API. Is that API enough? Right? Developers absolutely love APIs. Being a developer, not that many years ago for myself, I love APIs. It leaves everything open, gives me a bunch of different ways that I can connect. But what ends up happening is you end up having other people who want to get to the data within your application. And so you're at a conference, Cloud Expo number 11, and you present your new application, and somebody comes up to you and says, hey, I've got this business analyst, and he can't get to the data to run a report for my CEO because I can't figure out how to integrate your API into Microsoft Excel. And then on the other hand, you say, I've got this application, this BI app that I've been running for about 8 years, and I think it has a way to tie into REST, but I'm really not sure. We've been having it go against ODBC and regular relational databases, so I'm not really sure how that fits. So what you have to think about is how do you solve that? One of the ways that we think you can solve that we're helping our customers who run into this problem solve that, is by providing them a way of using SQL to actually stand in the gap that's created between a SaaS-based application and these existing BI installations that have been installed and up and running in some of these enterprises for many, many years. And it's just too expensive for them to change. Hadoop World this year is a great quote at Hadoop World at one of the keynotes, as they were talking about, the SQL versus the NoSQL versus NewSQL wars on, I really don't need to get to that data. What was really interesting is he got up on stage and he said, look, Hadoop is fantastic. I've been doing all my data processing there, but I spent hundreds of thousands of dollars on my BI stack, and I need to tie them together. I want to get to that data within my BI stack. How do I do that? And so that's what, there's many different options. One of them is you don't throw away what your developers love. You keep your APIs because you need them, right? The world is rapidly changing. You need to remain as flexible as possible as you're building your SaaS application. Now, one of the things that you can do, though, is you can take that API, and we have a product called Open Access. We actually have some customers here that you'll hear about how they've taken an Open Access SDK and built a data connectivity solution on top of an existing API to provide JDBC, ODBC, and or ADO.NET connectivity to it. This is one of the ways that you can connect their applications to your data. This is just some of the perspectives. Now, we do have another perspective that we want to cover. And for that, I want to make an introduction. Jamie Merritt, Director of Product Management, is going to come up here and tell us about a new product that we're going to be having. Please welcome Jamie.
Thank you very much, Jesse, for that long history of data connectivity. I really appreciate it. And thank you for waking me up in the middle. So I'm here, I'm very excited to talk to you about new products, and that's always what I like to do. So I'm going to try to answer that question of how do my applications connect to their data. So perhaps I'm writing a cloud app. I'm writing the next great SaaS application. And I'm writing an application that's going to help my sales force. And every time they go to a meeting, they're going to go out there and they're going to enter in their details of the details in the meeting. And that's going to update Salesforce.com or whatever CRM system they're using. Or I'm trying to connect my existing apps to their data. The key point here is I have an app, and I'm trying to connect to someone else's data because it's core to how my app works. So usually, well, that didn't work the right way. Usually, you ask a developer how to do this, and the first answer is, we're going to use the API. Salesforce publishes a well-documented API, lets you get at everything you need in there, through REST, through web services, through a number of different mechanisms. The problem is, once you build that into your application, you've built directly to their existing API, and you go to your customers, and now your customers tell you, well, I don't use Salesforce. Maybe I use RightNow, or maybe I use Microsoft Dynamics. Salesforce, while one of the largest games in town, is not the only game in town for CRM. Now, so then I'm faced with a problem. I need to then learn everything about the RightNow API. I need to learn everything about the Sugar CRM API. All of these APIs that you learn, it's real fun for developers, but it's a research project. Because yes, I know REST, yes, I know web services, but at the same time, I don't know the custom data models of those CRM vendors. I don't know what all the different operations are. So each of them is very, very different, even though they satisfy the same business function. So how am I going to build that? The same thing happens if I'm connecting to HR applications. So maybe I need to connect to Taleo or Workday or SuccessFactors. The key point here is that point-to-point based connectivity, building directly against the API, especially when you need to connect to multiple data sources, is extremely brittle. There's just too many APIs. They're all custom. Even though they use some standards, the standards don't give you sufficient ability to move between the different systems. There's no, as John showed before, the horses the lock-in and plug-in and horses changing. It's really hard to change which horse you're riding on if you build directly against a proprietary API. Furthermore, all of these APIs change very, very quickly. Salesforce updates their API every quarter. Many SaaS vendors update their API even more frequent than that. So not only have I built against their API, but at least every quarter, and likely much more often, I'm going to need to update my app to conform to the new API standards. And this quickly becomes way too many versions to manage, and it makes your head explode. The maintenance of all these connectors quickly becomes incredibly, incredibly costly, and it makes you take your eye off the ball. You're no longer building your app. You're no longer building the next best app for a sales guy. You're no longer building the next great cloud-based BI tool. You're suddenly just building new connectors and keeping up with those changes. The amount of people, time, and effort you invest in that quickly overruns what you expect to spend on that. That's not your core business. That's actually my core business, building data connectivity. I'm not building the next great app. I'm helping your apps connect to other people's. So I'm very excited to be here today to announce a better way of doing this. And it's interesting I say announce, because the press release has already gone out. And then because of scheduling, we sort of had an 8 o'clock session where I went through a little bit of this. But let's pretend none of that ever happened, and this is the first announcement of this technology. But I'm here to announce DataDirect Cloud. It's a connectivity service. So we're doing the hard work of SQL enabling all of these different SaaS applications. So I'm building a new app, or I'm trying to get one of my existing apps to talk to a new cloud service. I can go to cloud.datadirect.com. I'm going to say that a lot of times, so just get used to hearing that. But cloud.datadirect.com, and I can download one driver. That driver, if my clicker ever worked, there we go. One driver, ODBC, JDBC, Jesse already validated. People know what letters I'm talking about, so we know what ODBC and JDBC are. I take that one driver, I put it into my application, whether it's a BI tool, an on-premise app, or a new cloud-based app that I'm building. That driver allows me to connect to DataDirect Cloud, and then all of the connectivity sources that are behind DataDirect Cloud that we have already SQL enabled are now open to your app. So then when I'm building that next great app for my sales guy, I can build it against a single common API, against a SQL-based API that connects to Salesforce, Microsoft Dynamics, Sugar CRM. Right now, there's no changes that I need to worry about when I have to go between different sources or when I have to add a new source. All of it looks like standards-based SQL. And we do the hard work of making these data sources look like standards-based SQL, assuming that the data provider hasn't done so already. So advantages of this approach, as I said, standards-based access to the cloud. I already know SQL. My analysts already know SQL. I know one API. I know JDBC. I know ODBC. And I can use that to access this wealth of new sources that are available in the cloud. It allows me to, as I said, keep my eye on the ball. I want to build the best app for my customers, and I don't want to invest my time in data connectivity, especially when it comes down to keeping up with different versions of data connectivity and managing all those API changes. Jesse's actually 21 years old. He just looks older because he's been doing this as a business for this long. I mean, the reality is this is a lot of hard work, and companies are built around this. My part of my company is built around solving this problem of keeping up with APIs, keeping up with versions, and keeping them modern and keeping them current. But it's very hard, it's very expensive, and it's a business unto itself. And I don't think a lot of you want to be in that business. And finally, not only are you keeping your mind on your app, but you get new data sources essentially for free. Because when you need to add the new right now connectivity that you're already using Salesforce, you need to add Microsoft Dynamics. All of those changes take place behind the scenes. All of those changes happen in our cloud service, so all you're doing is configuring a new connection to your cloud service. So we see a lot of use cases for this. We see things like live analytics. So a lot of people, like those analysts that Jesse showed, the guy with the calculator up there, connecting to a variety of data that's stored in the cloud. So I want to do customer analysis. Usually this requires me combining information coming out of my ERP system. Let's say I'm using Plex Online as my ERP system, and my CRM data, my pipeline data. Let's say I'm using Salesforce as my pipeline data. Bringing that together into a live analytics environment is something you can do very, very easily with DataDirect Cloud. Why? Because we have an ODBC driver that plugs right into that application. So I don't need to wait for business objects, Cognos, MicroStrategy, Tableau, ClickTech, Excel, everyone to have their own connector to every single SaaS app I have. I already have a connector that plugs into my app and gives me that access that I need without waiting for my app vendor to provide that capability. Also, if I'm building on a new cloud platform, let's say I'm building the next great app and I'm going to deploy it on Force.com. I'm going to deploy it on Azure. I'm going to deploy it on Amazon Web Services. There's a myriad of options available to me. What I find with those platforms, I love them. They're great. Don't get me wrong. But they're very, very adept at allowing you to build applications that work within their ecosystem. When it comes to going outside, and let's say I'm building a Force.com app, they don't make it very easy to get Microsoft Dynamics data for good reasons. So we provide you an alternative which allows you to go outside of Force.com, go outside of Azure, and access a variety of data sources that aren't really as easy to connect to from there. And certainly for on-premise applications as well, there's still a lot of need for people to build new on-premise applications or to take existing on-premise applications and allow them to connect to the variety of SaaS services that are being used in their business. So today, remember, what we're doing is we're announcing the beta of DataDirect Cloud. I'm going to say it again. For more information, go to cloud.datadirect.com. And we have a couple minutes left. So I want to invite one of our product experts, Anthony, if you'd please join me up here and have to answer some questions. Thank you, Anthony. Give the mic.
Yeah, I have a lot of questions.
Yeah, I have questions too.
Really? Are you just one of those guys who claims to know all the answers to our data situation?
Yeah, I already need to use 12 APIs.
Oh, well, you can forget them all. We're here to help you guys.
I'm an account coordinator. How is this going to help me?
Well, pulling 10 reports from 10 systems is history.
Hey, come on. This sounds a little too good to be true.
And I'll show
Hey, maybe he's onto something here.
I think I get it, it all seems so clear.
Finally, something to bring these clouds. Together, we'll do away with the shroud.
Yeah, this is a little ridiculous. Don't you think this is a little ridiculous? Seriously. For real. You're gonna bail and head upriver. You overpromise and underdeliver.
But I don't know every API. About that guy.
Wait a minute. So now you're saying all of my worries of maintaining systems is done with ease?
Sing out loud.
Make your system sing out loud. Direct Cloud. Make your system sing out loud. With DataDirect Cloud. Oh, yes, sing it out. Make your system sing out loud. With DataDirect Cloud.
Chest bump.
That was so much fun. Hey, that's a pretty good idea. I like that DataDirect Cloud stuff. Yeah, DataDirect.
Thank you, DataDirect. The expo floor is now open. I don't know how you follow that.